In this question, it is given that let z is equal to a plus bi, where b is non-zero, be a complex number satisfying this equation. Then the least value of n, which is a natural number, such that z to the power n is equal to z plus 1 to the power n. First of all, we'll try to find all the complex numbers which will satisfy this equation. First thing, note that if z1 is equal to z2, this surely implies that mod of z1 is equal to mod of z2. But if mod of z1 is equal to mod of z2, this doesn't mean that z1 equal to z2 is surely there. But this implies this is surely there. But this thing I can surely say that all the complex numbers which satisfy this condition, some complex numbers will surely satisfy this. But all the complex numbers which satisfy this condition will surely satisfy this condition. And why I am telling you all these things, you will understand when I will take modulus on both sides of this. If I take modulus on both sides and try to find the value of z, means I am using this criteria. If this is equal to this, then this will be equal to this. And because it is easy to simplify this equation after taking modulus, afterwards what I will do, you will understand when I will do the question. I take modulus on both sides. I get mod z equal to z bar mod into 2 to the power 1 minus mod z whole bar. But this is positive real number and square can go outside. I get mod z square equal to mod of z, because mod of z and mod of z bar are same, into 2 to the power 1 minus mod z. And now I am going to divide by mod z. I am allowed this thing because b is non-zero, means z is a non-zero complex number. And because z is a non-zero complex number, we are allowed to divide by mod z. I get mod z equal to 2 to the power 1 minus mod z. Clearly, mod z equal to 1 satisfies this equation. That is, every complex number which will satisfy this equation will have modulus 1. But it doesn't mean that if modulus is 1, then z will satisfy this. Actually, I have to find the value of z. This I have got the conclusion that mod z is surely 1, and writing mod z equal to 1 in this, I get z square equal to z bar into 1. And because mod z equal to 1, this will mean that mod z square is equal to 1. This will mean that z bar is equal to 1. This will mean that z bar equal to 1 by z. And writing z bar as 1 by z, I get z square equal to 1 by z. That is z cube equal to 1. That is the value of z will be 1 omega square. That is, all these three complex numbers will satisfy this equation. And now if I take z equal to 1, then this cannot be equal to this for any natural value of n. But if I take z equal to omega, then this equation will mean omega to the power n equal to omega plus 1 to the power n. This implies that omega to the power n equal to minus omega square to the power n. And keeping in mind that omega cube is 1, it is obvious that the minimum value of n satisfying this equation is n equal to 6. Note that n is given to you as natural number.